Hey everybody, Mr. Longo here to talk to you about solving exponential and logarithm equations. You are going to need your calculator to do this, and you're going to have a lot of very ugly answers with lots of decimals. So we're going to be rounding to 3 decimal places to the nearest thousandth today. But you're going to need your graphing calculator to solve these equations. So if you don't have it, go grab it and click play when you're ready. So there's a lot of different styles of solving equations. And one of them is when you have your variable in the exponent and you have the same bases. So if you have the same base, the exponents are equal. So if we have b to the x and that's equal to b to the y, we could just set the exponents equal to each other because they have the same base. So for this first example, we're just going to set x plus 4 equal to 3x minus 6. Now I want to show you why that works, just so you know mathematically why we can do that. If you take log base 2 of both sides, remember those are inverses, so those are going to cancel. And that's what's going to leave us with x plus 4 is equal to 3x minus 6. And then, of course, you're just going to solve. So we're going to subtract x from both sides and have 2x and add 6 to the other side is equal to 10. So x is equal to 5. And we're done. And, of course, when you're working with exponential and log equations, you always want to check to make sure your answer makes sense, because you can have extraneous solutions. For example, we already learned that you can't take a log of a negative number. So in this case, if you were to substitute it, they would both be 2 to the 9th. So that's going to work out just fine. So you're going to look at the next one and you're going to be like, wow, I can't do this. But yes, you can. Because you have to always change bases to the smallest possible base. So 4 is actually 2 squared. And of course, that's to the 3x. And that's equal to 8, which is 2 cubed raised to the x plus 1. Now, another thing you have to remember is when you raise an exponent to another exponent, you're actually multiplying. So this is 2 to the 6x, and it's equal to 2 to the 3x plus 3. Again, take log base 2 of both sides, but since the bases are equal, you can just set 6x equal to 3x plus 3. So 3x is equal to 3, so x is equal to 1. And if you plug 1 back in, you would have 4 to the 3rd power, which is equal to 64, and 8 squared, which is also equal to 64. So it works. Just make sure you always check for extraneous solutions when you are solving for x with these type of equations. All right, so that's it when you have exponents with the same base. Now, the other thing we can do is going to have the same rule, pretty much, is logs that have the same base. So if you have log base b of x is equal to log base b of y, well then again x is equal to y. Now in the first one I will show you again how it's mathematically done and why we can just set 5x minus 1 equal to x plus 7. And that's because we have to exponentiate both sides. Because log base 3 as an exponent of 3 is going to be an inverse. So 3 raised to the log base 3 cancels, and you're just left with 5x minus 1. And that's equal to 3 raised log base 3, again cancels, and you're left with x plus 7. And now, of course, you just finished solving. So you end up with 4x is equal to 8, so x is equal to 2. Make sure you substitute it back in, because remember, you cannot take the log or a natural log of a negative number. So we have 10 minus 1 is 9, and 2 plus 7 is 9, and we can actually take log base 3 of 9, which is actually 2. So it works out just fine, okay? Next one in this row, we have the same base again. We're all log base e's, also known as the natural logs. However, you have an issue here. We cannot just say x plus 4 is equal to 12. Before you exponentiate both sides by e, you can only have one log or natural log on each side. So the first thing you have to do with this side is condense. So remember, The addition is actually the product property, where we would rewrite this as the natural log of x times x plus 4. And that would be equal to the natural log of 12. So sometimes if you have two logs on one side, you must condense. Of course, if you were to exponentiate both sides to e, that's how you would get it to go away. But like we set up here, if they have the same base, you can just set these equal to each other. So we have x squared plus 4x equal to 12 after you distribute your x. X squared plus 4x minus 12 equals 0. So we have x plus 6 and x minus 2. So x is equal to a negative 6 and a positive 2. So when x is equal to a negative 6, if we were to substitute that back in, we'd have the natural log of a negative 6, which we cannot do. So negative 6 is going to be extraneous. And then we would substitute in a 2, and the natural log of 2 and a natural log of 6, those are both going to work. If you were to condense that, 2 times 6 would be 12, so we're taking the natural log of 12 on both sides, so 2 does work. So proper notation, we have our solution 2 and our extraneous solution of a negative 6. Okay? So remember, always check your solutions. Okay? Now, we're going to get into the calculator and we're going to have some crazy looking answers. And this is because a lot of these are going to require the use of a calculator, and evaluating logs most of the time are going to have crazy decimals. So again, you need your calculator to solve the rest of these problems, and we're going to have to round to the nearest thousandth. So this is when we have different bases. There's multiple ways to do these at times, but for all of these, I'm going to show you the easiest way to do it. And the first way is we need to get our exponent, where x is, to be all by itself. So just like any type of solving equations, you've got to do the same thing to both sides. So to get x to not be an exponent, you have to take log base 2 of both sides. So log base 2 of 2 to the x is equal to log base 2 of 7. And that is your inverse, so that's where we get x. So x is equal to log base 2 of 7. So that would be your exact answer, but since we're going to be rounding to the nearest thousandth, you have to remember how to type that in your calculator. It's the change of base formula. So we have the log of 7 divided by the log of the base 2. And this one, x is equal to 2.807. And we're good to go. So if you were to raise 2 to 2.807, it'll be close to 7. Remember, that's because we rounded. So if we were to check it by doing 2 raised to 2.807, it's close enough to see that it works. Remember, we rounded. Log base 2 of 7 is actually 2.807354922, and if we were to just raise 2 to that answer, we would be good to go. Okay? So just check, make sure that it's really, really close. The next one, we have e raised to the 3x. So again, we need to get the exponent to not be an exponent anymore. So to get rid of an e, remember the inverse is taking the natural log of both sides. So ln of e cancels, so we have 3x is equal to the natural log of 12. And then you can type the natural log of 12 in right now, if you would like to. And we would get a decimal. And then we're going to have to divide that by 3 to end up with x is equal to, and then you would just press divided by 3, 0.828. Okay, so remember, it's easier to have a more accurate answer by just typing this all in. So you get the natural log of 12 and then divide it by 3. You don't want to say the natural log of 12 and then round this and then divide by 3, because then rounding twice means you're not as accurate. Okay, so just make sure you just type the natural log of 12 and then divide it by 3. Don't retype 2.485 in your calculator. Okay, and as always, when you're solving for x, you need to isolate the term. So the first thing we need to do is subtract 3 from both sides here. So we have 5 to the x plus 2. That's equal to 20. And now, to get this by itself, we have to take the log base 5 of both sides. And that's going to end up giving us x plus 2 is equal to log base 5 of 20. So of course you're going to have to type the change of base in the calculator. So log of 20 divided by the log of 5 is going to give us 1.861, but then of course we have to subtract 2 from both sides. So you can do it right now, minus 2. And we're going to end up with x is equal to negative 0.139. Okay? So I think you see by now that you're not going to be able to solve these without a graphing calculator, so please make sure you have one ready to rock. Okay, so we have a few more to go. Now this one's going to be a little bit different. We're not going to be taking logs of both sides. We're going to be exponentiating both sides. Same type of thing. We just need to make sure we have an inverse. So we have log base 5 of 3x plus 1, but it's only equal to 2. So unlike earlier where both sides were both log base 5, where we could just quickly cancel them or set them equal to each other. Again, I showed you how we do that. To get rid of the log base 5, we're actually exponentiating both sides. So now this becomes 5 raised to the log base 5 of 3x plus 1 is equal to 5 raised to the second power. So that's going to cancel those guys. So we have 3x plus 1 is equal to 5 squared. So we can just straight up call it 25. Subtract 1 from both sides. So 3x is equal to 24. So x is equal to 8. And we are good to go. Now the next one is pretty much the same type of equation. And then after that, it's pretty much the same as well. So why don't you try the last few on your own. Just press the pause button. As soon as you're ready, click play, and we'll be ready to rock. So for this one, of course, we've got to get this group all by itself. So the first thing you should have done was subtract 3 from both sides, giving us a negative 2. Log base 2 of x is equal to a negative 10. Divide both sides by a negative 2, and we get log base 2 of x is equal to 5. And now we just have to get rid of the log base 2. So again, we're going to exponentiate both sides. So we now have 2 raised to the log base 2 of x, which are inverses, so they cancel each other out, is equal to 2 raised to the 5th power, which we know is 32. And if you got that, you are good to go. Log base x of 9 is equal to 2. So we have to exponentiate both sides, but it's with an x. So x raised to the log base x will cancel each other out, and we have 9. And that's equal to x squared. And then we're just going to have to make sure we square root both sides. And x is equal to plus or minus 3. Okay? And then the last one, you had to first divide both sides by 2. So we have ln of x minus 2 is equal to 3. Now, to get rid of a natural log, remember you use e. So we're going to have a very crazy decimal for this. So after you exponentiate both sides with e, we have x minus 2. And that's equal to e to the 3rd power. And then, of course, we're going to add 2 to both sides. And x is going to be equal to, and then we need our calculator, of course. So we're going to have second e to the 3rd power. And then we're going to make sure we add 2 to both sides. And we end up with 22.086. Okay, and you can type that in and then add 2, it doesn't matter. Or you can actually just say that x is equal to e to the third plus 2. That's actually your exact answer. But if you're asked around, there you go. All right, so a long video because there's lots of different styles of questions you need to know for solving equations that are exponential or log. That's it for this video. This is Longo and I'm out. See you, bye.